So in this video, we're going to be talking about trinomials, that is factoring trinomials, and those are the equations that are in the form ax squared plus bx plus c equals to 0. And this equation here of this trinomial, that is the equation with x to the power of 2 as the main power, generally forms the equation of in the shape of a parabola. That is the graph with that looks like this, it looks like a cup sort of thingy, and the graph is facing upwards. And that has to do with the fact that in this particular case, a is positive. So when you look at this equation, a happens to be the leading coefficient of x squared, that is the highest power. B is the leading coefficient of x, that is the second highest power, and then c. The reason why I'm emphasizing on this is that sometimes you might get the equation, let's say x to the power of 1 being the highest power, plus b of x to the 1 over 2. Now this is the second highest power, right? Plus c. C happens to be a constant. Now a constant could be any number, like 5 or 7 or 3. Basically, this number doesn't change. But when we look at x could be 2, x could be 3, x could be 4, right? Depending on where we are on the graph. X could be any one of these values from 3, 4, 3, 2, 3, or 4, right? So when I say that the highest power of x gets the coefficient of a, right? And this is going to become useful whenever we're dealing with the quadratic equation, the one that says x is equals to negative b plus minus the square root of 4ac of b squared minus 4ac, all this over 2a. So this is to know that which one exactly is a, which one is b, which one is c, right? So that's it. So let's look at a couple equations. However, I do want to point out something on this graph, which is to say that this graph here is the graph of y is equals to x squared. This is when x does not have any a, it does not have any b, it does not have any c, it doesn't have any of that. It's just y is equals to x squared. And when we want to shift the graph somehow, let's say we want to shift the graph 1 unit up, we have to say y is equals to x squared plus 1. And this will form the graph that is in the form, we draw it like that, with here being an asymptote, here being a line. We can call that this is 1, right? But however, today we're not dealing much with graphs. I was just pointing out that this equation here, ax squared plus bx plus c, is in the shape of a parabola. We're going to be dealing with solving these equations. We're going to be dealing with factoring these equations. When we're factoring this graph, basically what we're doing, if we're factoring this particular equation, what we're doing is that we are finding. So let me say I have a graph here. Let me draw a fresh graph right here. And this graph sort of goes like this. What we are basically interested in, we are interested in these 2 points. What are the x values of these 2 points of intercept? So we can only find these 2 points. You can see that where x has any value, y is 0. So we can only find these 2 points when y is 0. So the equation is y is equals to ax squared plus bx plus c. And what I'm trying to say is that for us to solve for these 2x points, we need to set y equal to 0, and then say ax squared plus bx plus c. Right, so 0 is equals to all of this. Then we need to put 2 brackets. This is factorizing, and then we set the first bracket equal to 0, and the second, so I'm just going to say first equal to 0, and second equal to 0. And then from this point onwards, we solve for x, right? So let's look at a couple of problems that we can solve. We're going to do really simple problems today because just this is an introduction. And the first problem that we're looking at is if we have x squared is equals to 5x minus 4. Now when you look at this, you have the highest power 2, and then you have this one here. This is x to the power of 1. If they don't put anything next to the power, it means that it's to the power of 1. So the form that we must write it in the form ax squared plus bx plus c, set that equal to 0. And then we get to this point here where we have to equate the two graphs, the two brackets to 0. So here, first step, we can say that here there's an a value of 1. This is the highest power, so it is a. Here there's an a value of 1, so we can write it as 1x squared. Take this and move it to the other side. Take this 4 again and also move it to the other side. So when the 5 crosses the bracket, it becomes a minus. The positive sign that was here changes to be a negative. So it becomes minus 5x to the power of 1. And then we take the 4, we put it to the other side. But the 4 had a minus, so we change that, we put it to a plus. So this is plus 4. We say that this is equal to 0. Now from this point onwards, we don't have to write this 1 and this 1. We just know it's there. So we can say x squared minus 5x plus 4 is equals to 0. And then now we can solve. When we are factorizing this, we are looking for two numbers that will give us 4. Right? When we multiply these two numbers, it must give us 4. And when we add them together, it must give us negative 5. So that's pretty simple. Two numbers that I'll multiply to get positives form. The numbers can be either positive and a positive multiplying together, or they can be a negative and a negative multiplying together. However, you can see that this number that we're supposed to add to is a negative number. So it means that this is the only one that will work, because these are two positives. It's not going to work. So then this is equals to two numbers that can multiply to 4 and add to minus 5 is minus 4 and minus 1. So we open our two brackets, say x minus 4 and minus 1, set that equal to 0, and then equate the two brackets to 0. X minus 4 is equals to 0, and x minus 1 is equals to 0. So then we solve for x. We take this 4, we group like terms. We take the 4, we move it to the other side. So then this becomes x is equals to. When this moves to the other side, it changes the sign to become a positive. So this x is equals to 4, and x is equals to 1. So that's it for the first problem. Let's look at the second problem that I have here. So you can try this yourself. So here, this is x, 3 minus x is equals to negative 3. I want you to pause and try this on your own. By grouping the like terms, by grouping everything together. You know, there's this thing of Bodmer's that says that we must multiply this bracket out first. So yeah, I need you to pause this video and try this out on your own. However, let me do it. So now, the first step here is to multiply out the bracket. Bodmer says brackets of division. Brackets must always be taken out first. I don't know, I heard that they've changed it this time, it's bombed us or something. But what we do know is that brackets are always taken out first. So what this is equals to x times 3, that gives us 3x. X times x will give us minus, because you see there's this minus in between. So that will be minus x to the power of 2. And then is equals to minus 3. So now we're working from this side only. This is now equals to, we need to take this 3, we bring it to the left. So 3, and also we need to know that the power of x, the value of x cannot be negative, of x squared cannot be negative. So I think it will actually be better if we take x squared, we move it to this side, so that it changes its sign to a positive. Then this 3x takes it also to this side, then it changes its sign to a positive. So this becomes positive x squared. Then the 3x becomes minus 3x, and then the minus the 3. So now it's time for us to factorize. Again, now we won't be able to, because 3 is a prime number, we won't be able to find two numbers that will multiply to 3 and give us 3. So this is when we need to use our quadratic equation, that is negative b plus minus the square root of b squared minus 4ac. We divide this by 2a. So x is equals to, the value of our b is negative 3, so we say negative 3 plus minus the root of, so b is negative 3, we say squared, minus 4, a is 1, and c is minus 3. say this equal over 2a. The value of a is 1. So x has two values. So x, when you punch this into your calculator, you see that x is equals to 3 plus minus the root of 21 over 2. And the 2x values that we're going to get for this is x is either equal to 3,79 or negative 0,79. So that's it for the problem. Another problem that I want us to look at is factoring out the difference of two squares. If you have two squares, right, let's say some value a squared minus b squared. So this is the difference of two squares. There must be a minus in between the two perfect squares, right? What you do is that you say this equal to, obviously you're going to need two brackets because this is the power of the highest power is 2, so you need two brackets. Then the first one goes in the first brackets, and then the second one goes in the second bracket. And then what you do is that you change the signs. So if we have an equation to solve, x squared minus 4 is equal to 0. This will be factored out to, open our two brackets, we put x, now what are the factors what are the two numbers that we multiply to get negative 4? To get 4. So if we multiply 2 and 2, we'll get 4. So we put 2 here and 2 there, then we put a minus, then we put a plus. And those are your two factors for this, for the difference of two squares. Now that's it. I don't want to make this video for too long. That's it for this particular problems. We're going to have more videos with more problems. And that's it for this video. Thanks for watching. So